Hello everyone, welcome back to Creo Parametric. I am Rakesh VALASA. In this video lecture, I am going to explain how to develop a hexagonal headed bolt in Creo Parametric software. You can see this figure. This figure dimensions are given in terms of D. Let us take D equal 10 mm. So this diameter is 10 mm and this hexagonal headed bolt thickness is 0.75D, that means 7.5 mm. This bolt thread length equal to 2D, that equal to 20 mm, and this total length is L equal, let us take 4D, that means 40 mm. Okay, now open Creo Parametric new window. Now click on new and choose part and remove this checkbox and give the name is bolt, hexagonal bolt. You can type here hexagonal bolt, then click on OK. Okay, in that you can choose MMNS part solid, then click on OK. Now the new part modeling window is opened. First you need to choose the plane from this model tree. Here I am choosing the plane front and choose sketch and also choose sketch view. Okay, for easy understanding and easy visualization, you need to turn off this plane display. Then first you need to construct this hexagon in Creo parametric software. For that purpose you can choose palette. In the palette it's showing different types of polygonal shape. Among that I am choosing 6-sided hexagon. Just pick and drop in the screen and move and hold mouse left button from the center to move this plane center, then close this window. Okay, in this tab you can give the angle 90 degrees rotation and hexagon edge length is take 10 mm, then click on OK. Here also you can click on OK. Now you need to apply the extrude, then give the thickness. You know that hexagonal head thickness is 0.75D, that equal to 7.5 mm. You can type here 7.5 mm. From this drop down you can select symmetry, then click on OK. Okay, after this you need to apply the chamfer to this headed bolt. For that purpose I am choosing top and select sketch and choose sketch view. Then first draw the one center line at the center, then draw one triangle to this side or this side. So by using line tool I'm going to draw one triangle shape to the right corner, right side. Draw the horizontal line, vertical line and join with start point. Now exit from this tool, just click mouse middle button and give the dimension. Let us take this is 2.5, enter and you can enter the angle. For that purpose you can choose this side and this side. Click mouse middle button here and enter the angle 30, enter. Okay, after this click on OK, then apply the revolve. Here you can revolve around this vertical center line with 360 degrees, then remove this material. Now click on OK. Okay, after this, after applying the chamfer, then you need to construct this shank portion, that length equal to 4D, that means 40 mm. This diameter equal to 10 mm. So that purpose I am choosing this surface. With the help of mouse left button, select this surface and choose sketch, then select sketch view, then draw one circle by using circle tool from the center, draw one circle, then give the dimension, that is d equal to 10 mm. You can see it. Double click on this dimension, 10, enter. After this, click on OK. Then apply the extrude. This length is up to 4D. That means 40. 4 into 10, 40, enter. Then click on OK. Okay, once clearly observe the given image. In the right side there is no chamfer is there. If you want to add chamfer, you can choose this chamfer and select this curve, this circle. Let us take that chamfer dimension 1, enter. Then click on OK. Okay, after this, the next step is you need to create this thread portion from this end to this end is 2D. For that purpose, I am choosing helical sweep, helical sweep, references, define. The plane is top plane. Then click on sketch and also choose sketch view. Okay, after this, you need to draw one center line, then exit from this tool, then also draw the one reference line to this bottom edge, then close this window. Then with the help of line command, draw one line to either this side or this side. So I am going to draw one line to this right side from start point to up to this reference line. Now exit from this tool. Now click mouse middle button, give the dimension. This length is 2D, that means 2 into 10, 20, enter. Now you can change from start point this to this side. Now select this point, click mouse right button, it's showing start point. This is the way to you can change the start point from this point to this point. Okay, after this, click on OK. Click on OK. Then you need to create the helix profile with the help of this sketch option. Now change the view, sketch view. For thread profile, you can see one more sketch, that is I'm going to construct the triangle shape. So we know the one relation, we know one relation for h and p, that is h equal to 0.866p. Let us take pitch value 1 mm. So h value equal to 0.866. Here h by 6 means 0.866 by 6 equal to 0.144. Similarly, h by 8 equal to 0.866 by 8 equal to 0.108. So with the help of line tool, I am going to construct the triangle shape from this point to draw one triangle here. Now exit from this tool. Now you can give the angles. This you can take the equilateral angle. That means these three angles are equal. First you need to edit this angle 60 degrees. Similarly, you can give the angle to these two edges, this side 60, enter. Then give the pitch, this pitch equal to, let us take 1 mm, 1, enter. Next apply the fillet to this side. Select this line and this line. The next point is, you know that the distance between this corner point to this fillet point is h by 6. That means that equal to 0.866 by 6 equal to 0.108. 0.144. With the help of dimension, first point, second point, you can click here. This length is 0.144. Enter. One more point. Here okay, after this, after giving this length, that means h by 6 equal to 0.144, then click on OK. You can see it now. The triangle profile thread is created. Here two options are there, left-handed rule thread and right-handed rule. You can use any one of these. The default one is uh, right-handed rule. Here it is asking that enter a pitch value. We know that we have taken that pitch value 1. Enter. uh, Next one is, here one more option is you need to remove that material. You can see it now. The triangular profile is created. Okay, just click on OK. Here one more point. When you zoom this figure, this last thread should not be correct properly. We need to cut smoothly. So go to helical sweep, click mouse right button, edit this, choose edit definition, go to references, edit. Now change this view, sketch view. Just take line tool. From this point, draw one inclined line. Now click mouse middle button. With the help of dimension, you can give this angle in between this surface and that line 75 degrees. 75. Enter. And also you can take the distance between this point and this surface. That is, you can take 1 mm. Enter. Now click on OK. Now you can see it. The last thread is also cut smoothly. You can see it. Yes. Now click on OK. Okay, after this, once again carefully see the given external thread profile. Here h by 8 is there. So for that purpose, we need to select this surface and click sketch view, sketch. For clear understanding, you can choose shading with edges. Now choose sketch view. First draw one circle here with the help of circle tool. From the center point, draw one circle. Now click mouse middle button. Then with the help of references, select this surface, close this window. Now give the dimension in between this circle and this reference line. Now click mouse middle button here. This gap is h by 8. That means 0.866 by 8, that equal to 0.108. Enter. Now click on OK. Now apply the extrude. To this portion in the reverse direction. Up to 2D. That means 20 mm. 20. Enter. Now remove this material. And you can flip this direction. Then click on OK. You can see it. This is the final hexagonal bolt in Creo parametric software. You can also see the views. Go to the view, top view. Now you can zoom this image. You can see it. This is the exact profile. You can see the other side. The last thread is also cut smoothly. Okay, this is the way to construct any type of thread for hexagonal bolt in Creo parametric software. Okay, I hope you enjoyed a lot in the session. In the next video lecture, we will see the how to develop hexagonal nut in Creo parametric software. Thank you for watching. Please do like and subscribe my channel for more updates.